In this video, I want to talk a little bit about logistic regression, not just how to do it in R, but also, how to interpret the results, because I think that that's probably at least as important. So in the assignment, one of the things that you're going to start with is creating a new object called Spammy, and you're just going to read in the document or the spam.csv. Read it in. Once you read it in, you'll go ahead and you'll take a look at the header so you see what's going on. The background here is with this data set, we have a list of close to 18,000 or so emails that were collected. Again, this has been several years back, but that it was collected, and the emails were identified as either spam or not. And then once they were identified as spam, people went back through and they coded each one of those emails in particular to see if maybe there were keywords that should tip us off or maybe predict whether or not something was spam. Things like the word make. If make was in the email, was it what ended up happening? So everything was coded. If the word make was in it, a 1 appeared. If the word make was not in it, it was a 0. And you can see other words that were in here were address and all and 3D and, and some other ones like free, may have more emphasis as we go through. So again, we've read this in. This tells us whether or not the word was in the file. And then finally, if you look down here, the last thing is spam. And spam says whether the email is spam email or not. The first few that are in this group are all spam. Spam, if it was spam, it would be a 1. Otherwise, it would be a 0. Okay. Next thing that you needed to do is to go ahead and create a new object called spam fit. And spam fit is a general linear model, which is what logistic regression is. Logistic regression is it is linear regression. However, this time we're going to use a binomial fit for it because it's using a logic function. All right, so the way we're going to do that is spam fit is a general linear model. We're going to use spam, and then this symbol, and then nothing means throw everything into the trash can. All right, throw every one of our variables in, and let's see if we can predict spam based on everything. Data is spammy, family is binomial. Again, we have this binomial distribution. It's either going to be one of two things. It's either going to be spam or it's not going to be spam, okay? So two things. I'm not trying to predict an entire line. I'm just doing a binomial. Is it spam or is it not spam? All right. Again, it comes up with a warning and says, all right, we're just going to give you two things here. It's either going to be a 0 or a 1. And we're like, perfect, that's what I'm looking for, because logistic regression is saying, can I predict something, yes or no, based on whatever rules that I put in place. All right, once spam fit is created, let's look at a summary of it. The summary of spam fit gives me coefficients for every one of my different columns or variables that was in that file. We knew it was going to do this because we told it up here, give us everything in the trash can. You come through here and you look at the estimates, and with the estimates, a few things to take a quick look at. One of them is the probability. What's the probability that this occurred just due to chance? If you scroll down a little bit further, you can see that if it's 3 dots means that there's a less than 0.001% chance that it occurred just due to randomness. 2 asterisks is less than a 0.01% chance that it was due to randomness, and so on and so forth. All right, so this is the column. And what does it mean? That's where we go next with this. So what I want you to do is take and copy this information, and let's go to Excel to take a look at it. Okay, when you paste this back into Excel, those coefficients need to come in. They should look about like this. You're probably going to have to do some formatting just to get it in there, but you get the idea. Get it in here, and I want us to start thinking and talking about what logistics regression gives us. This coefficient to you means absolutely nothing. If you read through the chapter 1.3 in the textbook, it will tell you that this coefficient is really, if you take e and raise it to this power, then that gives you what they refer to as the odds. All right, so I want you to add a column, put in odds, and you can see here's a formula for it. E equals exp, that's the exponent at that power. This says that the word make, if the word make is there, the odds that it's going to be a spam email is 0.6. Well, odds also equals the probability divided by 1 minus the probability. Okay, so odds is not something that we normally play with unless you're in Vegas a lot. So let's go ahead and let's move past that. One of the examples that he does use in the book is that the odds for the word free is 4.67, which means that there's 5 times as great a chance of it being spam as not being spam. Let's go ahead and convert that to probability. Again, odds equals P minus 1 minus P. If we rearrange this equation, what we get is that odds divided by odds plus 1 is the probability. You can see that I've formatted this as a probability by clicking on percent, increasing the decimal point. So the probability of it being spam is now calculated here. Also, the opposite is true. If it is spam, it's 38.1%. However, not spam probability means that if the word make appears in this email, there is a 61.9% chance that it's not spam. And how did I come up with that? The sum of spam probability and not spam probability has to equal 100. So again, all I've done is 1 minus the spam probability. I extend these to where it's now looking at every one of these words. Put this in perspective real quick. If I am looking at emails, and in these emails, I go through and say I want to come up with a new policy that takes and puts email into quarantine based on certain types of words, how would I do that? What would it look like? What would be the 2 good words or maybe 3 good words that might help me? If I go down through here and look, the word remove. If the word remove is in the email, 92.5% of the time, it's a spam email. Okay. Similarly, for free, 82.4% of all of the spam emails had the word free listed in it. Okay, so this is kind of giving me ideas. Wait a second, let's maybe set up a policy that says, let's go with remove first. So if we now go back and say if I'm going to use the word remove, and every time the word remove is in an email, I'm just going to go ahead and list it as spam. Here's what I want you to do. Go back over to your other data sheet, copy the column spam and copy the column remove. Put them side by side. This one says that the very first email was listed as spam. However, the word remove did not show up in it. Okay? And go ahead and list those all the way down. That tells me that there are 3 different scenarios that kind of play into my prediction now. One of them is that we would have predicted it as spam based on the word remove. It was spam, and so therefore this is true, right? We did the right thing here in predicting. However, the second part is the word remove is not here, So I should have predicted this as not being spam. However, it is spam. So that's a false negative. You can see if I pull down here that the opposite can occur. Ooh, I need to come down quite a bit further. The opposite can happen where I can get a false positive if the word remove was in it. However, it was really not spam. All right, 3 different scenarios. It either we predicted it correctly, a false negative, or a false positive. I want you to put in an equation here to automatically, look at these 2 things and tell me whether or not it's a false positive, false negative. And let me take you back over. I'm going to show you a different formula so that you see it. Okay, and so the formula would look like this. If this equals this, then it's true. Otherwise, if this is greater than that, it's a false negative, else it's a false positive. Okay, so that's what I want you to do for the remove prediction. And the remove prediction really says I'm using the word remove to predict whether or not it's true. The next step that I want you to do is a pivot table to count up the number of false negatives, false positives, and true. So again, for this first one, false negatives will have 1,049, false positives 43, and then finally the true is 3,509. And if I take and calculate the percentages for each one of those, using just the word remove, I could correctly get 76.3% of all of my emails categorized correctly, either as spam or not spam. So again, let me say that again. If I just used the word remove, I could get 76.3% of all of my email correct, either as spam or not spam. However, 22.8% of the time, I'm going to get a false negative. I'm going to say it's not spam when it really was spam. Or I'm going to get about 1% of the time, I'm going to get a false positive where I say, no, this is spam, but it really wasn't. Is this a better model than what we were using before as just saying, everything is spam or not spam? If we go back and look at the data, 1,813 of the items are spam and 2,788 are not spam. So if I just chose to treat everything as spam, then I would only be correct 39% of the time. However, if I try to treat everything as not spam, I would only be correct about 61% of the time. So either choosing the policy of make everything spam or everything not spam, you can see that they're using the word remove does help us in identifying. This is a better model. Just use the word remove. Now let's look at the word free. See if free does anything different for us. We're going to do the exact same thing. Let's copy and paste free in. Let's categorize the whether or not we were correct. This is going to look very similar to what we had before, other than now we're looking at this column, predict everything, run a pivot table using just the word free. And whenever I'm looking at free, a couple of things will pop up at us. One, we get an overall increase just slightly on the number of, or on the percentage that I get correctly. But my false positives before were only at 1%. Now I'm up to false positives of 5.5%, and my false negative number falls a little bit. When this could really matter to us on this false positives and false negatives, think about, a false positive or a false negative when we're looking at a medical study. There are some times that if I'm given a false positive, and for a while I think that I'm positive for some disease, that may be a really bad thing. Or on the opposite side, what happens if I get a false negative It says that I don't have COVID when I really do. So there is this, whenever we're trying to create models as business analysts, we need to think about the models and whether or not we are creating situations to where, we are creating what percentage of our items are false positives, which are false negatives, and which one are correct. Okay, last one that we'll do is what happens if I use either the word remove or free. Again, I'm just trying to predict whether it's spam or not. Remove or free. In this column, I'm saying just take whether or not it was the word remove was there or the word free. So that's really just taking and adding these two together. Create the column, adding the two together. If it is a 0, it means that neither of the words was there. If it is a 1, it means one of the words was there. If it's a 2, it means both were there. Let's create a new column here and say, let's not worry about the 1s or 2s. Let's just say if neither word is there, it's a 0. If either of the words are there, it's a 1. Okay? There's a formula that'll help you get there. And again, last thing we're going to do, use similar coding as before to say, is it correct? Did I get a false negative or did I get a false positive? Run that through and then let's check this last model. This last model says if remove or free, either one were there, then what happens? And you can see here, using this new policy, we could accurately, categorize 82.5% of all of our emails by just looking at the words that were in the email. Can you start to see how you could use that from a machine learning or an artificial intelligence perspective? What I'm trying to do is just use the data, create rules, help me classify something as either a spam or not spam. Hopefully this helps give you a little bit of insight and gives you some ideas of how you could possibly use logistic regression.